Saraswati Sisukunj Bakwala Bursad, English Medium Standard 7, Subject Science. This is Semester 2, Unit Test 2, Revision, and in that question number 4, A and B, both questions we are going to see here. So let's start with question number B first, that is, answer the following questions in detail, right? So here see first question, write difference. Now there are two differences in one question only. Means one difference between like real image and virtual image, it is of 2 marks, and concave mirror and convex mirror, it is of 2 marks. Means total marks of the first question is 4, right? In this section all questions answer if you will write, right? So you will get total 8 marks, right? And any 2 you have to write for that. Okay, let's see first answer. Here real image and virtual image, right? So let's see answer. See here, real image. So the image can be obtained on a screen. Real image always can be obtained on a screen. Now virtual image we cannot obtain on a screen. Virtual image cannot be obtained on screen. Here you can see this is for real image and this point is for virtual image, right? Now let's see about second point. This real image is always inverted, right? This real image is always inverted. If we talk about virtual image, so this image is always erect, right? Virtual image is always erect. So this was your first difference between real image and virtual image. See the second difference, that is concave mirror and convex mirror, right? Right now I'm talking about mirrors, so don't get confused between mirrors and lenses. So let's see answer. Concave mirror, first one, see, its inner surface is shiny. Concave mirror's inner surface is shiny surface, and in convex mirror outer surface is shiny surface, right? Outer surface is shiny surface over here in convex mirror. Okay, see the second point, an image formed by it can be real or virtual. I am talking about concave mirror. The real image that formed by concave mirror, it can be virtual or it can be real also, right? It forms only virtual image by convex mirror. Okay, now the third point, it is of application. So what is the concave mirror's application? So concave mirror is used in searchlights, right, and headlights of the vehicle. Here the convex mirror, it is used as a side mirror in vehicles, right? This is used as side mirror in the vehicle. Let's see again, concave mirror inner surface is shiny, convex mirror outer surface is shiny. Concave mirror, so real and virtual image both can form in concave. In convex only virtual, always virtual image forms. Concave mirror used in searchlight and headlights of vehicle, convex mirror as a side view mirror, right, or side glass. So this was two difference. First question is done. Let's go for second question. Look here, to make an electromagnet from given iron nail. Now here what we are going to do, we are able to see here, so this is your nail, right, and this is wire, this is wire, coil like wire. Now how it is, wind like this, like coil, it is on the nail, right? And this is your electric circuit, this is your switch, right, and this is your cell. Okay, so and here small nails are there, right? Now what will happen with this practical? Let's see. So materials that is required from the figure you can easily write: iron nail, insulated wire, electric cell, electric switch, and small pins. Okay, now so let's see procedure. So procedure, like first one, take 75 long piece of insulated wire. It can be of plastic or cloth, right? It should be flexible wire, and the second one is iron nail. The length of the iron nail, it could be 6 to 10 centimeter long. So these are the things that we need to take. Now what we'll do, now second point that we need to do is here, wind the wire tightly around the nail in the form of coil, as I told you, right? How we have to do? Around the nail we have to tie the wire, right? Around the nail we have to tie the wire in this form, right? Okay, now connect the free ends of the wire to the terminal of a cell. through a switch. Using switch, we need to connect these terminals. Now here in the figure you can see, this is your switch, this is open end which is connected here in the switch, and this side it is connected in the cell or a battery, and this wire also connects in the battery, right? Okay, now see the next point. Place some pins on or near the end of nail. Now here any side you can put, any side you can keep the pins. If you want to put this side, then also here also you can keep the pins. Both side you can keep the pins. Now what will happen? Now switch on the current, means switch on the current, and that current will flow inside the wire. What happens? Do the pins cling on the tip of the nail? It is get attracted. Cling means it will attract slightly, it will move from its position, right? 6 number, switch off the current. Now switch it off. What will happen? See, are the pins still clinging to the end of the nail, or now it is not clinging, right? Okay, so now let's see observation. The coil of wire behaves like magnet. The coil which is on the nail, it will behave like magnet. When electric current flows through the wire, flows through the coil, as a result the small pins cling on the end of the nail. Now because the nail is in the contact of coil, so it will behave as magnet and all pins will attract towards that nail. When electric current is switched off, the coil generally loses its magnetism. When you are switching off the current, it will loses its magnetism, and so that the small pins will fall off on the nail, right? Now small pins will no longer connected with the nail because current is off. Okay, see the conclusion. When electric current flows through the coil of an insulated copper wire wounded around that nail, it behaves like magnet. Such a coils are called electromagnets. Means this coil is known as electromagnet. Which coil? Not whole connection, this coil, this part is electromagnet, right? This whole structure will behave as magnet, right? And that is why the pins which were here, it will stick to the nail, right? Okay, let's see next question. Third number question, write short note on fuse. So fuse is kept in the electric circuit in the house. We are keeping fuse in the circuit. Now where we are keeping it? So the mainly fuse is generally kept besides the electric meter, right? Where we are keeping the fuse? Besides the electric meter. Okay, a piece of thin wire, it is of special type of material. What is the material type? So it can be alloy, tin or lead. The material which is used for wire which is inside the fuse, it is alloy of tin and lead. It is tied, or we can say it is kept or put inside the holder made of porcelain, right? The holder which is made of porcelain, that wire is kept inside that, such that it joins part A and part B. That wire will join part A and part B. The fuse wire is such that it melts easily, right? When there will be more current, then will be more power, so it will melt easily, right? When the amount of electric current in the electric circuit exceed, right, the limit of the current, if it will increase than that limit, then the wire which is in the fuse will melt. This is called, the fuse is blown off, right? What it is called? When the wire will melt, that condition is known as blown off, right? Okay, due to blown off fuse, electric circuit becomes open. Due to this, the circuit becomes open. Now when circuit becomes open means there will be no any current will flow inside your house, right? So that the electric current stops flowing to the electric devices which is in your house. Thereby they are prevented from any damage. Means all the electric appliances now they are prevented from any other damages. Incidence of fire is also stops. Means by heavy current sometimes your electric appliances which is in your home can be damaged. It can be short circuit in your house, so it causes lots of danger for the people who lives in that house. So it is also prevented now. In the case of blown off fuse, new wire can be tied and fuse again starts working. Now 4 number, state the principle of electric bell, explain its construction and working. So this is your bell, this is hammer, right? This is soft iron bar. This is soft iron bar which is attached with the hammer. This is screw which can be adjusted, right? Actually this part which is so small, it is your switch, right? Okay. Now this part behaves as electromagnet when current will flow, right? Okay. And this part is also little bit flexible part, we can say, which is attached with this. What is the principle? Magnetic effect of current. Here see, this is coil, right? This is coil, right? When current will pass from this coil through this circuit, when current will pass from this coil through the circuit, this part will behave as electromagnet. Now when it will behave as electromagnet, this soft bar will get attract towards this magnet here, this side. But when it will move this side, right, this screw, right, it get detached. This screw will get detached from the bar. Again I am saying, when it will attract this bar, right, this screw will get detached. Now when it will get detached, there will be circuit break, right? The circuit becomes open. Now when circuit becomes open, the current will stop flowing from the circuit. Now when current will stop the flowing from the circuit, now again this becomes a normal iron bar. So again this part will go back to the main position here. Now when it comes again back to the normal position, the circuit joins again, it becomes the closed circuit, and again this part will become your magnet, right? And again it will attract. So this happens in very few seconds, right? This thing happens in very few seconds. Okay, let's see. Now construction. First one, figure shows, right, as we have observed in the figure, it shows the circuit of an electric bell. A coil of conducting wire wound on the iron piece, right? There was a U iron piece you have seen, right? Here there is an iron piece on which there is a coil which is connected, wound. Okay, so continue in the process. The coil acts as a electromagnet. The coil which is on the iron bar, it acts as a electromagnet. A soft iron strip is kept close to the coil. The soft iron strips which is kept so close to the coil which is electromagnet, right? A hammer is fitted at its one end. Here we have seen, right, that hammer, it is fitted on the electromagnet, right? Okay, see here, a metal bowl, it is fitted with the screw. Metal bowl means this is your metal bowl, this one, it's your metal bowl, right? It is also fitted with the screw. See 5 number, one end of the electromagnet is fitted with the soft iron strip, right? Here you can see one end of the electromagnet, it's fitted with the soft iron strips here, right? It is fitted here, and other end it is with switch over here, you can see, right? Now let's see working. So first one, see, on pressing the switch, so where is the switch? If you have observed in the beginning, I told you where is the switch, it is here. See, this is your switch. So when you will switch it on, the current will flow and this part will behave as a magnet, that is electromagnet, right? So the electric current will flow through the coil, right? The electric current will flow through the coil, and hence that coil will behave as a magnet, that is electromagnet. Hence now the soft iron strip is attached. The soft iron strips, it is attached towards the electromagnet. That soft iron strips, if you let's go again back to the figure. This is your soft iron strip. This is your soft iron strip will get attract towards the magnet, right? Now see the third one. At this instant, the hammer fitted on the end of the iron strip will strike gong. Now what is this gong? Gong means the bowl, the metal bowl which is connected here. This is the gong, right? Okay, so when circuit get completes and coil behaves as an electromagnet, instantly, right, the hammer fitted on the end of the iron will strike that gong of the bell to produce the sound. However, when the electromagnet pulls the iron strip, when the electromagnet pulls the iron strip, the contact of screw with the strip, see here, the contact of screw with the strip will breaks, and so the circuit breaks, right? What I am saying it, see here, when it will get attract, so the contact of screw with the strip will breaks, so the circuit will also breaks, right? The current flowing through the coil stops, right? Current that was flowing from the coil, it will stop. Now the current will pass, this thing will get attract over here, this strip, right? When it will get attract, it will detach from here. Now when it get detached, right, so the flow will stop because circuit breaks, right? Now this is open circuit, so circuit will break, and that is why there will be no any current will flow inside the coil, right? Okay, see 5 number. The coil is now no longer electromagnet and so cannot attract the iron strip. It happens in seconds, this whole process happens in seconds. Okay, that's why you are able to hear the large ring from the bell, ring. There is a, ring, it is longer than your imagination, and this process is so short, within a second. Okay, see here again 5 number. The coil is now no longer electromagnet, so it cannot attract the iron strip. The iron strip comes back to the original position and touches and contact that screw again, right? It will touch that screw again. The electric circuit becomes complete again. When it will touch back, the electric circuit becomes complete again. When the iron strip comes in a contact with the screw, electric current flows through the coil. Now again it is in the contact. Again, when it comes back, again it will touch here. So again your circuit is complete now. So again this one will behave as electromagnet. Again it will attract and again bell will ring. So this is your process, right? Okay, let's see the next point here. 8. Hence the coil again becomes the magnet and again it attracts the iron strip. Again it will behave as a magnet, again it will attract that iron strip, and again that bell will strike that gong, right? Iron strip and the hammer strike the gong. The hammer will strike the gong again and produces sound. This process is repeated quickly, right, successively, and hence the bell rings continuously. If you are keeping that switch on, so that process, it happens continuously, right, successively. So that is why your bell rings continuously. Okay, so this was the how it working of the bell, right? Okay, let's see the next question now. Explain in detail and show that the image formed by plane mirror is literally inverted. Now this you can do at your home even. What is the procedure? See here, stand in front of the mirror, look at your image. Raise your left hand, observe the image of your hand formed in the mirror, right? What you have to do, observe your image inside the mirror. Observe which hand of the image is raised, right? You have to observe that. See 3rd number. Now touch your right ear. Touch your right ear and observe your image. That which ear it touched by your image. Okay. Which ear does your hand touches in your image? Observe carefully. Okay, now observation. It you can do yourself, right? We did it in live class also, right? You were standing in front of mirror. Okay, see here. Right hand is raised. When you are raising left hand, the image will raise right hand, right? Okay, next one, see here. In image, left ear is seen as touched by hand, but what we are touching here? Right ear. See, we are touching right ear and image is touching left ear, right? So in short, if you want to say, so in short, in case of the image formed by the plane mirror, left part of the body becomes right part of the image. Left part of the body becomes right part in the image, and vice versa. Vice versa means left becomes right for image, right becomes left for image. In the plane mirror, right appears as a left and left appears as a right. So what will be our conclusion? So conclusion is, this shows that the image formed by plane mirror is literally inverted. Image formed by plane mirror is literally inverted. Okay, so now let's go for 6 number question, that is to observe heating effect of electric current by using nichrome wire. So here in the figure you can see this is your nichrome wire, these are two nails, right? This is your thermocol sheet, this is copper wire, this is your switch, and this is your cell. Okay, so which apertures are required here? You can see a piece of nichrome wire, right, which is alloy, electric cell, switch, two nails, and piece of thermocol sheet. Okay, so let's see now process. Take about 10 centimeter long piece of nichrome wire and tie it between two nails, as you can see here in the figure that nichrome wire is between two nails, right? Now what you have to do, you have to fix those two nails at some distance, right, on that thermocol sheet. Now make an electric circuit as shown in figure by connecting two nails on the electric cell through the switch, right, as shown in figure. What was there in the figure? See here, two nails are here, right? Now two nails, and between nichrome wire you have to connect, and then with the help of copper wire it goes in the cell, and here one end from the cell it goes in a battery. From switch one wire goes in a battery, the other wire goes here with the other nail. So this kind of circuit you have to create. Touch the wire when switch is off. This is your initial position, right? Touch the wire when switch is off. Now what you have to do, switch that on, so electric current will pass through the circuit, right? Now after few seconds touch the wire, do not hold it. When you are turning the switch on, again you have to touch the wire. How you are feeling that on that finger, right? Touch it and take it away. So what you feels on that finger, that you have to observe. Now again switch that off. After few seconds, after few minutes, touch that wire again, right? Okay, now what is observation? So see here, nichrome wire remains at room temperature. In first case here it remains at room temperature when the switch is off. Now when wire gets hot, when the switch is on, right, when we are keeping the switch on, when we turn the switch on, the wire becomes hot, right? Okay, so that is the nichrome wire gets hot when electric current passes, right? When electric current passes, nichrome wire becomes hot. So what is our conclusion? That when electric current flows through nichrome wire, right, electric current flows through nichrome wire, part of electric energy converted into the heat energy, hence the wire gets hot. This is heating effect of electric current. So that is your heating effect of electric current. Okay, so now let's see question number 4, that is give scientific reason, and it is of 6 marks. Any 3 you have to write, means 2 marks each. Okay, see first one, fuse is kept in electric circuit, right? So let's see answer. What is the answer? Sometimes there is a possibility of over increasing the strength of the current, right, which comes in your house. So it may causes damage to the electric devices. When that current increases than the limited fixed amount, right, then it can damage your electric appliances which is in your house. Now due to fuse kept in the electric circuit, when the current exceeds the safe limit, it quickly melts. The fuse wire will quickly melts, and hence the electric circuit becomes open circuit, right? When that fuse wire will melt, the electric circuit becomes open circuit, right? As a result, electric current entering the house stops, right? As a result, the current which is entering into your house, it will stop. Thus the electric devices and electric circuit are saved from the damage, right? It can damage even your electric circuit which is in your house, right, and your appliances. So both are saved. Let's see second number. Copper wire is not used to make filaments of electrical bulbs. Now you have seen bulb, right? There is filament inside. You have seen filament, how it looks. So this is filament of bulb. It looks like this, right? It looks like this. So in this, copper wire is not used. So what is the reason behind that? See here, copper wire has very low resistance, right, due to which the bulb does not become enough hot. The bulb does not become enough hot because it has very low resistance. Hence it will not glow. If it becomes hot, then only it will glow. Now there is low resistance, so it will not glow properly. If electric current is passing through the bulb, then also it will not glow. Therefore, copper wire is not used to make the filament electric bulb. What is the purpose of bulb? So it can give us light, but when it will give the light, when that wire which is kept inside the bulb will glow, then only it can give light to us, right? But here copper wire is not glowing after passing the current, so that is why it is not used. Let's go for the third number here. A convex mirror is used as a side mirror in the vehicles. So why convex mirror is used? See here answer. An image of object which is placed at any distance, right, against a convex mirror is always obtained as a virtual. Whatever image you are getting in convex mirror is always virtual, even it is erect, right, and in small size than the original object. Now it is also behind the mirror, right? You can see literally inside the mirror, which is behind the mirror, so that image it easily can be seen inside the mirror. Now it also spread in the large area. See here, convex mirror can form image of the object which can spread over the large area, means you can see whole area which is behind, right? So the image covers large area of a road. When we are using convex mirror, so it will cover large area, hence the whole traffic of the road behind the viewer appears in the convex mirror. So it is used inside the mirror in vehicles. Now you just think that if you will use concave mirror, so the image will be inverted, but here in convex mirror the image is erect, means it is straight, not upside down, right? It is not upside down, it is erect, right, and virtual behind the mirror. Okay, that is the advantage to use this convex mirror inside the vehicles as a side mirror. Okay, let's see the next one. An electrician is carrying out some repairs in your house. He wants to replace a fuse by piece of wire. Would you agree? There is electrician and there is wire which is inside your fuse. The electrician want to change that wire. There is some repairing in your house, so he want to keep a piece of a wire, any wire he want to keep. So would you agree? If you are not agree, then give the reason why. So see here, we should not agree, right, to replace the fuse by piece of wire, because replacing fuse with wire, what will happen, will increase the risk of short circuit, right? If you will replace it with any ordinary wire, so it will increase the chances of short circuit, or you can say fire in the house. A fuse consists wire which is made up of a special material which melts and breaks the circuit, right, when there is excess of electric current passes through the circuit. So it should always use ISI marked fuse in our houses. So what we have to do? We have to use ISI marked wire in our houses. So that is the reason why we should not get agree. Okay, let's see number 5. Electric bulbs are considered as a bad source of light. Why electric bulbs are considered as a bad source of light? See answer here. So electric bulb consists of thin filament, right, which get hot and produce light when electric current is passed through that filament. So the heating up of the bulb leads to wastage of electricity, right? Heating of that coil, right, it is known as wastage. It is wastage of electricity, which is not desirable, right? It will consume more electricity, more power, right, and the light which produce, right, it is not in that much amount. Therefore the electric bulbs are considered as a bad source of light, and that is why nowadays you are seeing that most of houses are not using bulbs. What we are using? We are using LEDs, LED lights, right, LED bulbs, right? Okay, let's see next one. We must look for ISI marked on electric appliances before buying them. Why we need to use, means why we need to check this ISI mark? Why we need to look for that? So let's see answer here. ISI mark is a mark of Bureau of India, right? This is mark of Indian Bureau. ISI mark is a mark of Bureau of India standards, right? So there are some standards for any electric appliances which ensure that appliances is safe and wastage of energy is minimum. What they ensure by checking those appliances? That appliances is safe and wastage of energy is minimum, right? as we all know that every appliance or whenever we are passing current, there will be some loss of energy, but to ensure that there is a wastage of energy which is minimum, right, through them, therefore we must look for ISI marks before buying an electric appliances. Okay, let's see next one. A concave mirror is used as a reflector in the headlights of vehicles. See here answer. An electric bulb is fitted in the middle part of an concave mirror in headlights of vehicles. Rays of light emerging, this rays of light emerging from the bulb to get reflected by mirror. So those rays get reflected by the mirror and travel parallel very far away. It travel very far away, and reflected rays do not get spread even though we go very far away, right? They go very far away, then also it doesn't get spread more, right? It focus on some point, right? Hence intensive light falls on small area for some far distance, only for some far distance it will fall, it will not get spread more, right? It will fall on some specific part on the road, and that is why those reflectors are used. Okay, see 8 number. It is advisable not to see the sun directly through the magnifying glass, right? As you all know that magnifying glass, it is convex lens, and convex lens will converge the light, right? Convex lens will converge the light. Okay, so let's see a specific reason for that. See here, a magnifying lens is convex lens, right? As I told you, convex lens is also known as converging lens, as it converges all the type of light falling on it. It will converge, it will merge all type of light which falls on it. Converging means, look here, see the figure. So this is light, so it will merge all here at some one point, right? Okay, so it is not advisable to see the sun through magnifying lens, because it will converge all the sun rays in your eye, right? It will converge all the ray which will fall, right? It will focus in your eye, that all ray will get focus in your eye, right? When it will fall in your eye, this can causes damage to your eye, it will causes damage. Hence it is not advisable to see sun directly from the magnifying glass, right? So this was your give reasons, right, and answer in detail that we have seen. Okay, I hope you understand it. If you have any doubt, we can clear in your live class. Thank you so much.